Hey folks, how you doing? It's Don Grant, CTC Cutting Tool Counselor for the Harvey Performance Company, here with another episode of In the Loupe TV. Thanks for joining us. Before we get started, subscribe, like, share it. If you feel like it, share it with somebody that you think might gain from the knowledge that we bring as a high-performance cutting tool company. Folks, on this episode, come here for a second. We have to talk about something that's very important. I've done a couple videos on this before. We've talked about circle segment cutters. We've talked about HMAF cutters. We call them HMAF cutters, Helical Multi-Axis Finishers. These are the large radius finishing tools. You know, the taper form, the oval form, the lens cutter, got a big radius on them. The software and the way we use these tools has gotten so much easier that I need to do another episode of In the Loupe TV explaining how to use these tools, where to use them, and how to apply them. This time, I'm going to use a software called Autodesk Fusion 360. It used to be Fusion 360. Now it's just Fusion. I'm going to show you how easy it is to use these tools in your application and how to get a good solid tool path and how to use them to take some of that fear out of hopefully HMAF cutters, Helical Multi-Axis Finishers. We're going to dive in using Fusion. Using Fusion? Using Fusion, that kind of rhymes, sound good. Maybe Fusion will use that as a logo. Using Fusion to program HMAF cutters. Hey folks, before we get started on this one, I want everybody to do me a favor out there. If you are using a circle segment cutter in your industry, please put in the comments how it works for you. Did it give you huge gains? Did you save a lot of time? Did you save a lot of money? And if it's not working, why did it not work? Put in the comments below so you can help all of our viewers out on how to apply these tools. Let's just start with the easiest thing. We're getting started here. We want to start using these HMAF cutters, Helical Multi-Axis Finishers. What do we want to do? They got funny shapes. They got funny radiuses. Here's what I want you to do before you even get started with your CAM software where you want to start programming these. I want you to go into the Helical webpage. I want you to go to this Resources tab. Click that Resources tab. When you see that Resources tab, on the right-hand side, you're going to see CAM tool libraries. Whatever software you're using, download the CAM tool libraries into your software. Now I'm going to download it into Fusion and I'll show you where that is in there. Download it because it has all the geometrical functioning of that tool. You don't need to put it in there. You don't need to add them. You don't need to look at the dimensions. You don't need to insert anything. The tools will come loaded in your software already ready to go and to create a tool path on. Doesn't get much easier than that. So folks, we have to pick a part. So I created a part that looks kind of like stator vanes on an aircraft engine motor. If you're not familiar with it, these are stators. They got these little blades that goes all the way around. I just created 3 of them. I had to create something. This is what I came up with. So before we get started, let's just run this whole part with a ball nose. That's normally how we would run it. Let's take a 1/2-inch ball nose, create a tool path on this, and for material's sake, let's say this is 15.5 pH stainless, which a lot of stators are made of that, so it's realistic. So I'll put speeds and feeds for 15.5 pH stainless. I'm going to do a step down at 10 thou with a ball nose, and we're going to run this whole cycle all the way through to see what kind of time we get. Now, if you look at the time, we're a little over 2 hours of machining time with a ball nose. So we got 3 options to finish these stator blades, right? I could use a lens cutter, but a lens cutter cuts on the bottom. Can't get into it because we're going to run out of time. I can use a taper cutter that has different angles that cuts on the side, but I might have interference issues based on the shank and where that's laying down. So my choice to finish this, other than a ball nose, would be an oval form. Oval form kind of stands up a little bit more. We're at a steeper angle, and it's going to be a good choice to finish each one of these blades And I think it's going to be the most economical to do that. So how do we run through that and do this on these stator blades? So when I look in the Helical catalog, 87980 is kind of jumping out at me. It's got the right radiuses, it's got the right reach, and I think we're going to use that tool in our program. 87980 is going to be the tool that we're going to use to do these blades versus a ball nose. Now let's run over to Fusion. Let's put this in the program and let's show you how easy I can create a toolpath on these 3 blades using an oval form cutter from Helical Solutions. Okay, so here we go. I'm going to show you how easy this is. I'm going to use an oval form. So in Fusion, they have a really nice new toolpath in their multi-axis. Let's go over to the multi-axis. Let's drop this down all the way at the bottom. You're going to notice a toolpath that's called Multi-Axis Finishing. That is the cat's meow. Cat's meow, that's kind of funny, but that's the cat's meow. That is the toolpath that you're going to be able to use circle segment cutters or HMAP cutters in. So we're going to open this toolpath, and if you're familiar with Fusion, what you're going to get is you're going to get a bar that's going to walk you through steps of how to get that programmed. We're going to walk you through that. So here's the beauty now, folks. This is the easiest part about that. The first thing we got to do is pick a tool, right? Because we want to use an oval form. So remember when I told you before, you can download our tools. We downloaded this. I've already put it in there. If I go to select a tool, I hit select a tool, I have a local file where I downloaded my files. I click on my local file. I put in the search button, 87980, bam. There's my tool. I select it, and guess what? It has all the shape, all the geometry, all the lengths, all the radiuses, all that stuff is inputted already into my tool path. It knows what it's going to use. It doesn't get much easier than that to start. Now how Fusion works, we go left to right. This is how you do it. It's really simple, really easy. Let's go to the next tab. This is a tool orientation tab. Don't need to do anything here. We're going to leave this as it is and skip it and go to the next tab. Do you mind getting the mouse off my face, please? I appreciate that. So we're going to go to the next tab, which is where all the magic happens in Fusion. This is our geometry tab. Now when we just look at the top of this, we got 4 boxes here. These are about the simplest boxes you can do. The first one is the machining boundary. None. Leave it on none. You don't even need to touch it. The next thing is the areas to machine. This is where we're going to get into meat and potatoes. What do you want to machine? You want to machine the wall? You want to machine the floor? Well, we want to machine the walls. So we're going to click walls on this one. When we click the walls, we want to know what types of passes we're actually going to use. Do you want to scallop or do you want to blend? I'm telling you, we're going to do a blend. That means we're going to blend the passes from the top to the bottom. The next thing, leave it on automatic. It can stay on automatic. So there's just 4 boxes in this software that we're trying to create a program with that oval form that we need to actually address. So we know we want to machine the walls, so it's going to ask you where's the floor. We've got to click and find where the floor is. So why does it want to know where the floor is? Because it wants the orientation of the tool. It's very smart, intuitive software. So we tell what the floor is. Obviously, this is the floor. We click the floor. Then it says, what walls do you want to machine? Well, let's pick all of these walls that we want to use that oval form on. Click, 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 click. I'm going to let it click them all. It takes a little bit to get through the walls. So how you been? You been good? Let's run through these. Things good at home? Weather's nice. I think it's good. All right, we click through all the walls. We get all the walls selected. That's all we need to do on this page. There's 4 things up top. We need to identify what we want to do. Then we need to tell it where the floor is. And we need to tell it what features we want to machine with that oval form. Now we can move on to the next tab. Okay, this next one's very important. We're going to skip the heights button. You don't need heights. It's 3D. It knows where the bottom is. It knows where the top is. Now we're going to go to the next screen, which is going to be very valuable for inputting our information into Fusion. The first thing that we want to do is we want to do our step downs. Now this is an oval form. I'm telling you, an oval form to a ball nose is a 4:1 ratio, which means the ball nose we're stepping down 10th thou to get our finish. This one's 4:1, so we could step this down 40 thou. Think about that, 40 thou, 10 thou to 40 thou. What kind of gains are you going to get in productivity? So now we can step that down at 40 thou, get the same RA. There's a little button here called spiral. click the spiral button. We don't want to enter and exit. We want to spiral all the way down to the bottom to get a nice, clean finish. And then, of course, we all know climb, conventional, or both ways. You know, I want to climb. We always want to climb. Give us the best finish. We click the climb button, and this whole sheet is now completed. And the last page, just to get it out, is all your linking parameters. This is how much you want it to stay down, things like that. Again, I told you this is not a training on Fusion. This is just to show you how easy it is to put an oval form. We get done with this. Here's what we want to do. We want to hit the little calculate button and see what kind of toolpath that actually created with an oval form and how difficult it really was. Now that's a pretty looking toolpath. There weren't a lot of clicks. We used an oval form. It knows the dimensions because we downloaded the tool and we inputted them incorrectly. And now we got a very clean toolpath. Let's sim this and see what that looks like. Looks pretty nice. Cutting very well. And we're saving a lot of time because don't forget our step down is 40 thou versus 10 thou. So now we can use an oval form. We can run this tool. We can create a very easy tool path with an oval form. We can cut very easily and we can save a lot of time. Now just look at these. Let's look at these side by side. We used a ball nose before, the 10,000 step down. I actually think you're probably going to have to step it a little bit closer to get your RA. But we used a 10,000 step down. When we run this in 15.5 pH stainless on these three parts, we're a little bit over 2 hours. I just put in an oval form. You saw how easy it was to program this. I put in an oval form. I stepped it down 4 to 1 to get your same RA. 4 to 1, 40 thou, ran the same cycle, and now we're just a little bit over 30 minutes. Think about that, over 2 hours to 30 minutes just by going an oval form, and we actually put this in there very easily in this software. There's a lot of different softwares that do it very similar, very easy. It's easy to run through, but don't forget, download the tool libraries. It'll save you a lot of trouble on making sure the forms and everything comes out correctly. So folks, what's the lesson on this video? What's the lesson on this video? The lesson on this video is, please, if you're doing surfacing in your shop and you're running a 5-axis machine, please look at multi-axis finishers, HMAF cutters, we call them, helical multi-axis. Call us, ask us, challenge us, give us a part, let us take a look at it and see if we can put in an oval form, a lens form, a taper form, or something to accelerate your finishing. We'd love to look at it. Might not be right for everybody, but we can help optimize your cutting tool process with these HMAF cutters. I want to see more people out there using these tools. Well, folks, that's it. Thanks for coming. Thanks for joining. If you have any questions, put them in the comments. We'll answer them. But bring those specific applications to us so we can help optimize your machining. Watch these videos, ask a friend, put some comments. Hey, if you're successful with doing HMAF cutters, put it in the comments. That would be great too as well. Before I go, just remember, there's 3 guarantees in life, folks. Death, taxes, and spring passes. Have a great rest of your week.